In this video, we will talk about consumer functional interfaces. So suppliers that we covered in the last video, they don't accept anything, but they return some value. And just opposite are the consumers. What consumers do, they accept some value, they do something, but they don't return anything. Now there are different variations of consumer. There is the generic consumer, then the primitive specialization of the consumer, int consumer 2, that receives an integer and does something but doesn't return anything. Similarly, long consumer receives, accepts the long value and does something on that value. Then there are buy consumers. What they do, they receive two values. So the generic consumer and int consumer, they receive a single value. Buy consumer receives two values. And then there are different variations of buy consumer as well. For example, object int consumer, what it does in object int consumer, one value is the object, some object, and the second value is integer. Similarly, obj log consumer has two values. The first object is again some kind of object, and the second parameter is the long value. So we will see all these things in detail. Let's start with the consumer. So this is the consumer interface from the JDK library, and we see that it is a functional interface because there is this @ functional interface annotation, and it has a single abstract method with name accept. So it accepts some value but doesn't return anything. It is supposed to do something on that value. There is another method in the consumer interface, but this is default. It's not abstract. So there is only one abstract, which is accept, and then is a default method. So that's allowed in the functional interface. And then can be used to compose some behavior. We will see a quick demo on it in a short while. So let's start with the code demo for the consumer. Now, to do that, let me create an employee class first. And because we will simply have getters and setters, so we can also use record. So it has an integer property and a name property. That's it. We don't need to generate getters and setters, and it's all we need. So what we want to do is, for example, we want to create a generic consumer of type employee consumer, and we know that it will accept an argument because that's there in the method definition. So it accepts a value of type t, and in this case t is employee, so the input parameter will be of type employee. So we know that it will accept something, so let's name it emp, and then it will do something on that emp. Now it's up to us what we will do with it. It cannot return anything, so whatever it does, it will have some side effects with no return value. So for example, just to keep things simple, we can simply print the employee ID. All right. Now if we run this consumer, to do that, we simply say we will call the accept method, and we need to pass an employee object. That employee object will be passed down to the lambda when it runs. So let's create an employee object, employee emp1, new employee. Let's say the ID is 1 and the name is employee1. So we have the employee object, we have the employee consumer that accepts a type of employee, an object of type employee, and then it simply prints the ID on the console. Then we are calling the accept method of the consumer that requires the input parameter of type employee. So we simply pass the emp1. Now if we run the main method, we see the ID on the console. So that's the generic consumer and how we call the accept method on it. Now let's say we have to print the name as well. What we can do is we can simply append the name here, emp dot name, or we can use the and then method of the consumer. All right. So we can call the and then method on the consumer. What it does, first, it will call the consumer that we have defined. Then it will call the another consumer that we pass to this consumer. So it's basically a chaining of the consumers. So for example, we say that employee consumer is basically to print the ID of the, okay, so let me name it so that it's clear. We say this is the ID consumer because it is printing the ID only. Now we will create another consumer of type employee, but this time to print the name. And here we say name. Now we will chain these two consumers together. So first we say that we need to print the ID, and then we need to print the name consumer. Name, so we pass the name consumer, and then we pass the employee, which is the input, employee one. So if we run this code now, what it will do, first it will invoke the ID consumer on with that employee. So we should see the ID on the console, and then it will call the name consumer, the second consumer, with the same input parameter. So we should see the name of the same employee on the console. And if we run the code, we see the ID and then the name of the employee. So that's how we chain the consumers, different consumers. And this is the example of the generic consumer. Now moving on, similarly, we can use the primitive consumers. There are three primitive consumers: int consumer, long consumer, and double consumer. So this was the generic consumer because it was accepting some type of object. Similarly, if we only want to deal with the integer or primitive values, integer, double, or maybe long, then we should use the primitive type of that consumer to avoid the boxing and unboxing, same as the suppliers. So let's say we define an int consumer. So it will accept an integer. Let's name it input. And what it will do, it will simply print the double of that number. We don't need to call the system.out.println because that will be done by the int consumer. We simply need to call or trigger the int consumer by passing a number. So if we pass the value 5, then we should see the value 10 on the console here. So that's how we use the primitive consumers. Now let's move on to the by consumer. We can comment everything, and in the new tab, let me open the by consumer. So here if we see the documentation from the JDK, this is the by consumer interface, functional interface. It has the same accept method and the and then method. The only difference is instead of accepting only one value, it accepts two values. That's why the name by consumer. And these two values can be of different types, T and U. T and U could be same or different. It depends. The important thing is it accepts two values and does something on those values. And similarly, and then method of the by consumer accepts a by consumer. Okay. So let's create a by consumer, a generic by consumer. Let's say the first type is integer and the second type is string. So what we are saying, this by consumer will accept two values, one integer and the second string. And we name it by consumer. So the first value is integer. So we say it I. The second value is some string. Let's name it string. And what we want to do is we want to simply print I and then this string. Okay, to call it, we call the accept method, which now accepts two parameters. So if we pass the first value, which must be the integer 1, and the second value, which must be the string, let's say string 1. Now if we run the main method, we see the print message on the console, which is basically to print the input integer, which is 1, separated by this arrow and then the string 1. So that is the by consumer. And similarly, we can chain another by consumer in the same way that we did with the generic consumer. We can do the same thing with by consumer. The only difference is in the end, then we would pass a by consumer. So this was the generic by consumer. Now, if you notice, we were using the wrapper of integer. So obviously there could be, or there must be, a primitive consumer to accept the integer. And there are several primitive consumers, for example obj int consumer. So let's open it and let's see what it does. So this is the primitive specialization of the by consumer. Now it, for the first value, it accepts an object, that's why the obj in the name, and the second value must always be integer to avoid the boxing and unboxing. So let's do the same thing, but this time with obj int consumer. So let me initialize obj int consumer, and now we need to only provide one type because the second type is fixed, which is the integer. So the type that is not fixed, we will use string for that, and we say obj int consumer and str, the first value, the second value is the integer, and the same thing. Now this time we will call the obj int consumer dot accept. So the first value must be string, we pass it 2. Second value must be integer 2. And let's run the main method. So we see the same output, but there are two ways to do the same thing. One is with a generic by consumer, and the another way is to use the primitive specialization of the by consumer. Similarly, we can use the obj long, where the one value could be anything, any object, but the second value will be the long, primitive long. All right. So here in this video, we covered how to use the by consumer, how to use the generic consumers, primitive consumers, and primitive by consumers. Hope it helps. That's it for now. Thank you.